To solve this problem, we will use the theory that we have learned in Olympiad Challenge Problem 1. Without knowing the theoretical portion that we have learned in Olympiad Challenge Problem 1, we won't be able to solve this question. 5 boys and 5 girls go to an exhibition. See, application of this method that we have just learned. 5 boys and 5 girls go to an exhibition and the cost of ticket is rupees 50. So what's the important thing? Cost of ticket is rupees 50. Each girl has a 50 rupee note. Each girl has a 50 rupee note. While each boy has a 100 rupee note. 100 rupee note. Okay. Stand in a queue at the counter and the cashier doesn't have any money in the beginning. Cashier doesn't have any money. Then the number of ways of arranging the boys and girls so that one waits for a change, so that no one waits for a change, is n into 100, 120 whole square. Find n. Give it a try. Now I'll give you the solution. So what should be our approach for this question? Even one student proposed this approach in the group, that if we draw a 5 into 5 grid, let me go back. Do I have a blank grid? No. Okay, let me use this. See, I'm showing you just one example. Clearly we can see for the cashier to have change, what can be the situation? That number of girls coming before the boys should be always greater. Girls should always come before the boys. Then only the condition will be satisfied. That thing only you need to understand. That is arrangement. Say girl, girl. Then one boy. Again a girl. Then boy, boy. One, two, three, four. 1, 2, 3, 4. 1, 2, 3, 4, 5. 4. This is a possible arrangement. Why this is a possible arrangement? See, I'm showing you guys. Two girls have bought the ticket, and now how much money the cashier is having? 250 rupee notes. 250 rupee notes. This is the cashier. How much money the cashier is having? This is 50 rupee note. Wait a minute. This is 50 rupee note. And this is 100 rupee note. Two girls, 250 rupee notes are available. Now one boy needs how much? One boy is having 100 rupee. And how much change does he needs to buy a ticket? 150 rupee. So in all the scenarios here, what the number of girls are more than the number of boys. Number of girls are more than the number of boys means that girls are coming before boys. In that scenario only, the cashier is having surplus of change so that he can pay the boys. Because the boy is paying him 100 rupee and the cashier is having change of 50 rupee. Change of 100 rupee. He will pay back the boy 150 rupee note. So this is the scenario. Now let me draw another scenario where this case is not being satisfied. Say, boy comes at the first position. Boy comes at the first position. The cashier is not having initially any cash. The cashier is not having initially any cash. What will happen? The boy will give him 100 rupees. But the cashier is not having any cash. So now the cashier will ask the boy to wait so that the next person with a change will come. Say next a girl comes. She gives the cashier 50 rupees for a ticket then he can return the boy. But in this scenario, where the boy come before girls, we can clearly observe that the boy needs to wait for cash. But here in the given question, it said that no one waits for a change. No one waits for a change. So this is a invalid scenario. This is a valid scenario. Now we will draw this valid scenario in a 5 into 5 grid. In a coordinate plane. We'll draw this valid scenario in a coordinate plane. Let this axis denote girls and this axis denote number of boys. For this particular arrangement, I'm interested in this particular arrangement. I'll draw this arrangement here. Fantastic. Little bit more changes. Let this axis denote girls, this axis denote boys. This is the first position, okay. First position, one girls comes. I'll go one girl. Let me, this is the first position. This is our first step. Okay, this is our first step. So let me write the steps 1, 2, 3, 4. Actually, this is written as in this form: one, first step, second step, third step, and so on. That is in the reverse order. I am writing it in the reverse order. Here, this denotes the step 1. Here, this denotes the step 1. In the first position, a girl comes in the first position. Then this is the second position. This is the third position. Now, I want to write it in this form. Okay, so let me write it in the reverse order. That would be girl, girl, boy, girl, boy, boy, girl, boy, girl, boy. Fantastic. So this is written in this order. This is our step 1. This is step 2. This is step 3. So on. So this is the first step. One girl. Second step. Let me draw it using the red color. One girl, one girl. Then we will go one boy. One boy. This denotes one boy, two boy, three boy. Is the boy axis. Got it. Again one girl. Two boys. Two boys. One girl. Up to this we have drawn. One boy. A girl. And a boy. Let me write it now in the reverse order. for more clear visualization. Reverse order means I'm just shifting the diagonals. That's it. Shifting the axis, not the diagonals. What am I saying? This axis now denotes girls. This axis now denotes boys. Two girl, one boy. One girl, two boys. Two boys. Girl, boy, girl, boy. Girl, boy, girl, boy. Now, can you see the number of girls are obviously more than the number of boys coming before? Number of girls are always coming before the number of boys. So, any path from 0, 0 is the starting point. And what's the ending point? 5, 5. 5 girls, 5 boys. Which satisfies the given condition. Lies below the diagonal. Lies below the diagonal. Then only this would be satisfied. I am drawing another case for you guys so that you would be able to understand. Let me draw a random case here. See, in this case, now let me write it. One girl, one boy. Girl, boy, girl, girl. For one girl, one boy, one girl, one boy. Three girls, three boys. Girls are always coming before boys. Number of girls are always coming before boys. Then they will not cross. They will never cross this diagonal. They will never cross this diagonal. So this is just the number of path from 0, 0 to 5, 5. The total possible arrangement of these boys and girls are just the number of path from 0, 0 to 5, 5 to 5, 5, which doesn't crosses the diagonal, That's the total concept of using this lattice path here. So what we will do, we'll just simply draw the line above the diagonal, take its reflection. This is the final path, final destination. Take its reflection. That's 1, 2. Sorry, its reflection will be here. And this reflected point is 4, 6. Number of arrangements should be simply number of path from 0, 0. Number of path from 0, 0. Number of path from 0, 0 to 5, 5. Subtracted by the number of path which are crossing the diagonal. That's the number of possible arrangements of boys and girls which are crossing the diagonal. The number of arrangements of boys and girls would be the number of path from 0, 0 to 5, 5, which are not crossing the diagonal. So that how would find the number of path? Total number of path from 0, 0 to 5, 5, that would be 10 factorial by 5 factorial, 5 factorial. Subtracted by the number of paths which are crossing the diagonal, that's the number of path from 0 comma 0 to the reflected point 4 comma 6. That's 10 factorial by 4 factorial 6 factorial. So these are the number of arrangements of boys and girls. Now here, while considering the number of arrangements of boys and girls, we consider that boys and girls are unique. That's not the case. No two humans can be unique. Here we didn't consider the boys and girls to be unique. We considered that all the boys are similar and all the girls are similar, but no girls and no boys can be similar. For a particular arrangement, say this arrangement, for any particular arrangement, what was the arrangement? Okay, let's go through this arrangement. For any particular arrangement, the boys and girls can arrange among themselves, because there are 5 girls, they can arrange in 5 factorial, and there are 5 boys, they can arrange it in 5 factorial ways. That's 120 square. And in the given question also, they have given this 120 square value. This was the original question, definitely. So that's why the difficulty of this question increased enormously. And what is the value of n? We can easily correlate that this is the value of n, this value. So that is the idea. Whenever you are asked to find the number of path from some a comma b to c comma d that is not crossing a diagonal or not crossing a particular line, we'll take the line above it. Draw the reflection of our destination. And would subtract it from the total number of path. We will get our answer. That's it.